2 squared. That's 4, then put a negative on it. So technically this is a negative sign and then 2 2's. So there's no second negative to cancel that first negative out. Here there was a second negative that cancels that first negative out. You guys see that? This gives people trouble on a lot higher levels of mathematics. So I'm not saying feel free to have trouble with it forever. I'm just saying if you have a little trouble with this right now, don't feel bad about it, but work on it. Does that make sense? All right. Anything else from the quiz? I try to make this first one very bare bones, very nuts and bolts, very do you know how to do the basic arithmetic. Don't forget you can make corrections on quizzes. So if you get an 80 or higher, I'll give you a maximum of 5 points back. If you correct all the ones that you lost points on, and get them all right. You with me? You'll never get below what you made in the first place, so it's always good to try corrections out. At the worst, you'll just stay the way you are. You get all the corrections wrong for some reason. If you get 80 or if you get below an 80, I'll give you a point for every 4 you missed. So if you get a 68, that'll be an exciting part of the video. That's what I thought it would be, exactly. Maybe like retweeting it and saying, hey, go take a look at my math professor falling on his face. Oh, if you get below an 80, you get a 68. How many points did you miss? You get a 68. 32. Divided by 4 is 8. You can get 8 points back, max. If you do all the corrections, get them all right. All right, grade the hell out of corrections. So if I get a feeling at all that you just copied from somebody else or something, then I won't give you points back, and I might not let you make any corrections anymore. So don't do that. Make sure it's your own work. I've had people copy from somebody else, but the other person had a different version of the quiz. I mean, make it more difficult for me than that. That's pretty easy to pick up on. Okay. Any questions from homework? Any questions from homework? You're doing the homework, right? Sweet. So I'm going to assume that means it's going pretty well. You're still upset about that negative. Don't worry. I'll give it to you. Don't worry. Give me after class. Let it go. Breathe in. Breathe out. Then you'll suck it. No love for Friday. Yeah.
From 2.1, 84,
2.1 number 84. All right, so 2.1 number 84. Okay, good. I like this one. So it says number, absolute value, and opposite of number. Because the absolute value is not the opposite of the number. It's not how it's defined. The absolute value will always make the number come out to be positive because it's based on distance. It'll at least be 0. The absolute value 0 is 0 because 0 is 0 away from 0. Good Lord, how many zeros can you have in a sentence? So here, the number they give me on number 84 is negative 13. In this case, something will happen that doesn't always happen. What's the absolute value of negative 13? 13. What's the opposite of negative 13? 13. Yeah, the number. So they're always talking about this number. So the absolute value of this is 13. The opposite of this is 13. What if it would have been, here's my example. What if it would have been 8? What's the absolute value of 8?
8.
Beautiful. It's not negative 8. It does not change the sign. It just always makes it positive. It's already positive. So it doesn't have a damn thing to do. And then what's the opposite of 8?
Negative 8.
Negative 8. 11. Any other? Yeah. The same section?
What if 87 is the opposite?
Oh, 86? '86 is a little more evil, and then I'll do that one. Yvonne, who just asked me that? Number 94, right? Okay. Real quick, I want to do 86 since it comes right after this. Number 86 is a little more evil. They don't tell you the number, they tell you the opposite of the number. Well, then now I know the number. If the opposite of the number is 90, what's the original number? Negative 90, 11. And now, what's the absolute value of negative 90? 90. 11. Is that cool? So there's a few gimmies on the homework right there. So number 94. Let me do it. '94 references this chart, the boiling temperatures of various elements. So of course water. Now the scale here is Celsius. Of course we're used to Fahrenheit in the States because we like units that don't make much sense here. Right, the rest of the world uses Celsius for the most part, where 0 is freezing and 100 is boiling. That makes sense. Here it's 32 is freezing and 212 is boiling. Why not? Sure, what the hell. Anyway, so it's a little crazy. 94 says, which element has an average boiling temperature closest to positive 300 degrees Celsius? So there are, of course, there are certain things that whose boiling point, the point at which they actually boil and become steam, become vapor, is below freezing. Thankfully, oxygen does that, or else we'd be swimming. Well, that'd be fine. We'd be like fish. Swimming. If oxygen didn't become vapor below freezing, if we got cold enough, all of a sudden all the oxygen would turn it into liquid. That would be a little freaky. Right. That's all science. It's not math, so let's not go there too deeply. Which element has an average boiling temperature closest to 300 degrees Celsius? So for example, I see iodine has a boiling point of 184 degrees Celsius. But there's something closer to 300. Yeah, phosphorus has 280 degrees Celsius, and that's the closest I can get to 300. What has a negative? Like I said, oxygen does. Thankfully, so does hydrogen and helium. That'd be kind of freaky if you got a little cold, your balloon suddenly has liquid in it. You know? Just drink it, then you have that high voice. Right? Okay. Any other questions from? All my science jokes are falling flat.
Can you go over number 3?
30? In that same section 2-1? Okay. So 30 has this idea. Yeah, so this whole section, this
that's
little...
already number 3, I'm sorry.
Oh, 3.
Yeah.
Let me do this one real quick.
Okay.
Which one of these is bigger?
13.
13. And sometimes people know that, but they miss up on the symbol. Of course, it should be that symbol. This would be the one that looks like an L, so that would be less than. So right now, I want greater than. All right, so I just wanted to do that part. Number 3. I like it. The peak of Mount Elbert. I had no idea we had a mountain called Elbert in Colorado. It is 14,433 feet above sea level, and they want you to write that as an integer. Now, if you look at the back of the book, I kind of disagree with them. Are you going to put a negative sign on a mountain's height? No. Do you have to put a positive sign on it? Of course not. It's an understood. So if you write this as the answer, 14,433, I'm cool with it. I think if you look at the back of the book, they have this, not a T, but a plus. That's not necessary. You don't have to do that. If it's not there, we know it means that it's positive, right? So you just put that, I'm cool with it. The only places you got to be careful, of course, is if I'm, we had the problem earlier about scuba diving. I'm probably negative, right? What else? If I dig a hole to China, I'm probably at some point negative. Probably at some point got to realize they ain't going to work, but oh well. You guys got it with me? Or if my company loses money, I'm probably going to write that as a negative, right? Or in red, if you're accountant. How are we doing so far? Is that cool? All right. Anything else from the homework? Yeah.
So when it's like exponential integers, whatever, if it's like a -6 minus positive number, so they go to the left, or they go to the right.
So anytime I subtract a positive, I'm going to go, that means I'm getting that one on the number.
Positive number, so without.
Yeah, if I subtract -6 minus 8, that means start at -6 and go down 8 from there. Now, where it gets a little confusing is if I have -6 minus -8. That to me is a lot more confusing. And how can you make that a lot less confusing? What's the first thing you can do?
Cancel out the negatives.
Yeah, the two negatives make. And what would -6 plus 8 be?
Positive 2.
Yeah, positive 2. Oh, somebody $6, I find $8. Hey, I can pay him off and have $2 left over for a crappy lunch. At least it's something, right? So this is 2. This would be what?
-14.
Careful. Yeah, they're the same sign, so I add them. 6 and 8 makes 14. And then I put the sign back on negative. Oh, $6. Oh, somebody else said $8. I owe $14 altogether to various people.
I thought that was too negative.
I love it. So we talked about this last time. When do two negatives make a positive? When you're doing what operation? Multiplying. Because multiplying by a negative literally means the opposite of that number. So when I see something like this, in fact, we just saw it right here. What's the opposite of 8? 8. It's only when it's multiplying. Only when it's multiplying. And in this case, those parentheses really kind of do mean multiply. Right? Those two things together. How are we doing there? So be real careful. Just keep in mind, if I'm just doing this, think of it as debt. I can't add more debt to myself and make my debt go away. Although as a student, that would be really helpful. Because that's all you're doing is freaking adding more debt to yourself. But -7 minus 11, it's got to still be negative because I owe all this money to these people. I'm not out of the hole yet. Is that cool? And that could be real confusing because that rule is like drilled into your brain. Two negatives make a positive, but it's only when you're multiplying or dividing. If I subtract something from a negative number, it's only going to get more negative. Okay, cool. I know.
What if we do -7 divided by minus of what?
Let's do what we can do. Let's do like -14 divided by -7. Is that good? Okay, so the two negatives cancel. 14 divided by 7. So when you're dividing or multiplying, those cancel. And to me, division is a little easier to see. I mean, what's 8 divided by 8?
1.
Why? Because the 8's cancel, don't they? So what's negative divided by negative? Well, they cancel. I mean, so for me, division makes more sense. You can just see the negatives going away. You can see them cancel. It's the multiplication that makes it a little less sense, but just remember that it means the opposite of. So if I have -7 times -2, those two opposites cancel. So then you're left with just positive 14.
So if it's dividing or multiplying, cancel it?
Exactly. Dividing and multiplying, any pair of negatives will cancel. When you're adding, subtracting, think of it as debt. Can't erase your debt by throwing more debt at it. Right? So it seems like government is trying to do everything. Yeah.
42 of the column one.
Okay. This is section 2.2. This is the right problem, right? Okay. So this is the only way they can really make this more difficult. So first get the rule down. And I think the rule that really keeps us safest for adding, subtracting is if they're the same sign, you add them. 7 and 11 is 18, and you put the sign back on. If they're different signs, you subtract them and put the sign of the bigger one back on. Right? So those two rules help you through addition and subtraction. Multiplication, division, two negatives cancel. That's the rule. That's awesome. One rule for that. Two negatives cancel. Boom. So this is not multiplication, division. So I've got to use that rule for addition and subtraction. How can I, and here I can just go straight through. There's more than one way to do this. I'll do this the most direct way first. I can just start going straight through. It's all addition. Order operation says, I ain't got nothing to say. Just do it. There's nothing to do first here. You with me? So what's 18 plus negative 9?
9.
Exactly. Because if you wanted to, you could rewrite plus minus as just minus. And plus minus as just minus. Now, to me, that's just easier to look at. There's not an overabundance of signs now. So 18 minus 9, 9. 9 plus 5, 14,
12.
11. So what's another way somebody could do this? Yeah, 18 and 5 is 23. Negative 9 minus 2. And what's 23 minus 11? Same answer. The order operations did not let us down here. It says if it's all addition, which is basically what it is, it's all addition or all multiplication or anything, you can do it in any order you want to. Addition and multiplication, the order doesn't really matter. 7 plus 2 plus 3 is the same thing as 7 plus 3 plus 2. Who cares? You with me? A little bit, okay. Is that cool? All right. This is the whole reason why I don't like Scantrons in math, is because I like to get into your thought process a little bit. And very often, some student will do something very creative. Maybe their high school teacher showed it to them, or maybe they created it themselves, and I like it, and I start teaching it. So I steal a lot of my teaching stuff from my students. Why not? Any other questions? In section 2.2? Says find the sum of negative 30 and 15. So it's a little bit of a translation, right? Who remembers this? Find the sum of, okay, now what am I looking for? Find the sum of the next couple things, right? So I'm going to do what operation? Add this and this. Cool. So now I've written it in purely mathish, right? So from English to purely mathish, and now I can just attack it with math. See? That's how that translates, yeah. Now, it's not all they want, though. Now I've got to do the next step. So what's the rule here? There are different signs. So what do? Subtract. What's 30 minus 15?
Negative 15.
30 minus 15 is 15. Let me catch up to you. And then the bigger one is negative.
So you subtract those two?
So, since they're different signs, that's negative and that's positive, the rule is subtract in that case. So 30 minus 15 is 15. And then you put the sign of the bigger one on, negative. Which makes more sense. In this case, do I owe more money or do I have more money?
Oh,
So at the end, I still owe, right? So the idea of putting the sign of the bigger one back on makes physical sense. If my debt is more than the money I got coming in, I'm going to be in debt at the end. That's what that says. Which is a standard operating procedure for being in school. This is true. Any other questions from?
So negative plus positive equals negative?
Careful. I like that you said that because that's not the rule. If I had negative 30 plus 37,
it's plus two. That you got some.
the rule says they're different signs, so you subtract. 37 minus 30 is 7.
7.
What's the bigger one?
That is 7.
So the answer is positive. If I owe 30 bucks and I find 37 bucks laying on the ground, which doesn't happen. Can't I pay that dude off and still have money? So that's why at the end it should be positive. I shouldn't owe anything. Right? The positive outweighs the negative. The answer is positive. The negative outweighs the positive. The answer is going to be negative. That's why the rule says put the sign of the bigger one back on. That's the guy that's ruling the day there. Is that, you guys see it? So be careful about, that's why I like that you said that. Whenever I do problems, if I'm not careful to do enough examples at that time, people start making their own rules up. And it's not your fault, that's the way the human brain is. The brain is trying to make up rules by what it sees. But here the rule is, when they're opposite signs, you subtract, put the sign of the bigger one. The rule is not a negative and a positive makes a negative. You can add, right? That's not the rule. Yes, sir.
I thought it was like this triangle thing that tells you if this division or multiplication that it's like a triangle and it has like the two negative on bottom corners and the top corner like the positive. So that tells you like if this and this goes together is gonna be that, the third one, or if that goes together is gonna be that.
Oh, I see. I've never seen that. So like,
I think it's that way. I'm not sure.
so these go together. No, you gotta be
It's not that
careful.
way.
I think
But
that's
what it
for
works because-
multiplication division.
Oh.
Because if you multiply these, you get this.
Oh yeah, that's what I said.
If you multiply these, you get this. Okay.
But in the original rule for multiplying, I mean for adding and subtraction.
But it's not one. The rule is one that it won't be easy to put into a picture like that. Multiplication division is easy to put into a picture like that because it's a hard, fast rule. It's one rule. Two negatives cancel. Right? That's multiplication division. So it should be easy to put into a picture. So I've never seen that before. It's kind of cool. But for addition and subtraction, there's two rules. Now it's much harder to put a picture together. Maybe it's a trapezoid. Right? I don't know. Or wrong. It's not that. But yeah, I haven't seen it. But that's cool. I didn't see that. Yes, ma'am. 63 and 2-2. Oh. So we have, they give us this, right? And then they say evaluate if x is, where do we go? 3, and y is negative 30. That's what number 63 says. This is page 110, section 2-2. You guys with it? So what's the first step for evaluate? What do I have to do? Plug it in. 11. So it'll be 3 times, because I just plug that 3 in there, plus, good. And in general, it's a really good idea in general. Just whenever you substitute numbers in, just always put them in parentheses. That'll maintain whatever's going on. Because this does say multiply, but if I didn't put it in parentheses, it would look like 33. Totally different problem, right? Parentheses, now I know that means multiply. Cool. So 3 times 3, of course, what do you do first order operations?
Multiply.
Multiply. 3 times 3? 9. How can I rewrite plus and negative? If you want to, yeah. Minus. Because a positive times a negative is a negative. Is that cool? So the 9 minus 30, what's the rule? They're different signs. Subtract. What's 30 minus 9? 21. Which one's bigger?
Negative.
Yeah, the 30's bigger, so you put a negative sign. I owe $30, but I got $9. I still owe 21.
How did you get that positive 30 again?
Oh, this is plus some minus. So how do I rewrite that better with just one sign minus? Yeah. Adding a negative is the same thing as subtracting. If I add debt to you, am I not subtracting money from you? So adding a negative is the same thing as subtracting. And it just looks cleaner when there's less signs everywhere. If you like plus and negative, you can keep that and work it from if it makes more sense. Any other questions from homework? All right, that's pretty good. I was afraid I wasn't getting any questions in mine. Got a bunch. I like that. Okay, so all I really have planned today, I'm going to give you and me a little break today. We're going to do just a little bit out of the next section and then head out. And you're all like, we would have known that. We wouldn't have asked so many questions. This is why I didn't tell you until just now. And we're actually going to do a little bit out of the next 2 sections, but the next 2 sections are really review stuff. We've already talked about multiplying and dividing negative and positive numbers. Yeah. Section 2.4 and 2.5.
Just do it on Thursday?
Second.
Just do it on Thursday.
Um,
I'm right here.
2-1 and 2-2 are due Thursday.
Yeah, 2.1 and 2.2 definitely due by Thursday. But if you get further, that you can turn in.
2 and 3 and 4.
You-
2 and 3 and 4.
What about?
Are they due next week? Or are they due Thursday too?
They'll be due, officially they'll be due a week from today.
Which one? 2.1 and then 2.
2.3 and 2.4. So I desperately want you to realize the rules boil down to this. I love you guys. You're in college now, so a lot of times it's going to be a little less regimented for you. So what's going to happen is if it's turned in after the day of the test, it's late. If it's turned in by the day of the test, it's fine. I'd rather not get a stack like this on the day of the test. So what I do is, and plus you guys need to know if you're on track or not. You don't want to do all the damn homework the day before the test because that's going to be terrible. So I do this whenever I finish lecturing over a section, a week later the homework is due. What that really means is you should be at least close to done with that section. If you're not, you're starting to get a little behind. If you haven't even started that section yet, you're pretty behind. You need to come see me maybe. You with me? You always have until the day of the test to turn something in. Yeah, when is the test?
26.
February 21st.
I heard somebody say,
Oops.
That's a little
the date
soon.
under it.
I got you. Test is a week from this Thursday. This Thursday being Valentine's Day. So I decided not to give you a test on Valentine's Day. That's my little gift to you.
Yeah, look at the date underneath.
Stay with me now. I'm going to show you what's going to happen the next few weeks. On this Thursday, I will give you a practice test. You with me? When I say I will give it to you, I will not give it to you and you will work on it in class. I will give it to you, you will work on it at home. The following Tuesday, I'll have the answer key. Practice test given out this Thursday. Here's my second gift to you. Look, I gave you 2 gifts on Saturday. Yeah. Exactly. For next Thursday. I love it. Cool. So I'll give a practice test out this Thursday. Next Tuesday, I'll have the answer key. Next Tuesday will be review day. We will do nothing new next Tuesday. We will just review. So next Tuesday, review day. Answer key given out for the practice test. This is basically how it will always happen before a test. Before a test will be always like this. The day before will be review day. The day before that, I'll give you a practice test. On review day, I'll give you the answer key. Can't beat that. How we doing? If you don't want to do the practice test at all, you don't have to. You don't have to turn that in. Please don't turn it in. I'm giving you the answer key. Don't turn it in. It's just for you. As little or as much of that as you want. Yes, sir.
Test on section 1 and 2.
The test will be on, as far as you make it, I think we should finish 2. So the test will be on chapter 1 and 2. Yeah. Is everybody with me? All right, sweet. So don't just not show up next Thursday and not tell me a damn thing. That's bad. If something bad happens or something you know something's going to happen, come see me. I can set up a date for you to take it. If you're sick that day, desperately sick, then email me or call as soon as you're physically capable, and we'll set something up. All right. Okay. So section 2.4 is about this kind of thing. Let me give you a little more interesting problem. Let's see. What operations are involved in that problem? Just multiplication, right? Good. So here's the beautiful thing about this. Whenever I multiply 2 negatives, what happens? They cancel. So any even number of negatives that are multiplying will always cancel. How many negatives do I have up there?
3.
I got 3, so I got an odd dude out. Let me pick my odd dude correctly so I'm not putting you guys on. So these 2 here will cancel. You'll have 1 left alive. So I already know my answer is going to be negative. Now I can focus on the numbers. 2 times 3, 6 times 1 times 1 is still 6. So you got to break it down like that. You can think about what's the sign going to be, and now let me just focus on the numbers. Or you could, negative 2 times 3 is negative 6, times negative 1 is positive 6, times negative 1 is negative 6. You can certainly do it that way too, whichever way you want to. But the idea of an odd number of negatives will stay negative, like it did there. An even number of negatives will always be able to pair up, and kill each other. Romeo and Juliet style. So what about? It was so sweet there for a minute. So I think I've shown you this before. This kind of thing. If I had that,
It's still a negative.
why is that a quick answer?
It's an odd number.
Yeah. 1 to any power is 1. Now the only question then is it positive or negative? I have an odd number of negatives.
It's negative.
Yeah, there are 10 of them that can pair up, and there's one guy on the corner going. So it's still negative at the end.
But he's happy because he's not dead.
Huh?
But he's happy because he's not
This
dead.
is true. After everybody dies, he's like, oh, okay, it's fine. Do not drink the Kool-Aid. I'm all right. All right. So let me, of course, throw in some other stuff here into the mix. Now, here I'm being slightly evil, possibly. If I ask you how many total negatives are up there, how many are there? 4. There's 1 there, 1 there, 2 there. There's 4 total. So this is a good one. Whenever I start throwing exponents at you, it might be better just to attack it directly. What is negative 3? Well, actually, order operations. What would I do first? And because of the way it's written, what do I do last?
Division.
Division.
Just because it's written with the big bar here, right? You don't always do division last. I just do the division last because that's what that big bar means. It means do the top, do the bottom, and then divide at the end. That's the only time you really have to do it last. So -3 squared, 9. And what can I do on the bottom here? Good, -1 times 3 is -3. Yes, ma'am. Because what does this square here mean? What's being squared? What's being raised to a second power? -3, right? So I have -3 times -3,
Positive 6.
positive 9. Yeah. Here? Here. Yeah, because it's to an odd power. That's the key. You guys with me?
So what's the key?
The key is, if it's raised to an odd power, a negative number to an odd power will stay negative. Why? There will be an odd guy out. There will be an odd negative sign out. Right? So if I had, for example, let me write something that's a little bit easier to look at. If I had -1 to the 5th power, isn't that -1 times -1 times -1 times -1? Please don't do this, by the way. Especially with -1 to the 48th power. So these pair up and die. These pair up and die. You still there? That's why it's still a negative. If it's raised to an odd power, or you have an odd number of negatives, the answer will be negative.
So when it's the 1 would have been positive and the 5 would have been negative?
Now be careful. Negative powers don't even go there yet. Negative powers, we don't even know what they mean yet. This makes I have 5 of these. What would -5? That doesn't really make sense yet. That's math 9. We're not going to talk about negative powers in here. They get a little freaky. But if the 1 was positive, obviously I don't care what number I put up there. It's always going to be 1 because it started positive. It's going to stay positive. And I don't want this to become any more difficult than just this. Any pair of negatives will cancel. That's where I'm getting all this stuff from. So if I don't have enough if I have an extra 1, it's going to stay negative. But if I have -1 to the 6th power, they can all pair up, so they all cancel, so it ends up positive. I love it. So over here, I have 2 -3s. So the negatives cancel. That's why it's positive 9. On the bottom, -1 times 3 is -3. And now there's a couple ways you can do this. You can just do it directly. What do I still have to do next?
Top.
Good, I got to finish the top out. 9 times -2, -18. What do the negatives do? Beautiful, they cancel. They kill each other. 18 divided by 3?
6.
Positive 6, I love it. So I really want you to understand. It's kind of bad that there's so many ways to look at these. Because as a student, you're like, I got to know all this. But from the beginning, I could have seen 2 negatives, 3, 4. I know the answer's going to come out positive from the beginning. But do you have to look at it that way? Hell no. You can just start attacking it directly, and then you go, it's positive. As long as the answer comes out positive, if you knew it here or knew it there, I don't care. So whichever way makes more sense, you do it that way. Yeah.
Why didn't it say 3 times 2?
I love it.
Because that's what you said.
Where did I say that?
You said if there's no parentheses, right, we divide it. We multiply, right?
So there's nothing to do in the parentheses?
Yeah.
What's the very first thing on please? Please excuse my dumbass son, or Jaren's son? Whichever one makes more sense. What's the P stand for? Parentheses. So there's nothing to do inside. What's the next thing? Exponents. So you have to do the power before you multiply. Which really only makes sense. I'll see my students in my math 180 class, right? These are the guys that are like, yeah, I know math. And then they do something like this. And now you bring negative into it. So can you guys see why this? I see this all the time in all levels of mathematics, but I want you guys to never make this mistake. This is a major mistake that has been made. It's not really fair, in a way, if you want to look at it that way. I have 2 whats up there. I have 2 3s. How in the world did that become 2 6s? That is magic. That is David Blaine. Right? Here I have double 3 squared. So order operation says my ass. Order operation says you don't multiply until you've done the exponents. So the right way to do this is twice 9, which should be 18, not 36. So see, let me see if you guys are with me. I only have 1 2, but I have 2 3s. If I had 2 2s and 2 3s, that would actually work. But I only have 1 2. See how that's why that is twice as much as this. This mistake here is kind of like thinking you have more than 1 2. That's crazy. More importantly is just do order operations. Powers before you multiply. That will keep you straight. When do order operations stop? What level of math do we suddenly not care about order operations? No level of math. My math 285 students must do order operations when it comes up. Period. It's just the truth. It's just something that's always true. Don't feel like, oh, we're out of that section now. I don't have to worry about order operations. No, it's always there. Always. Because I've actually had a student say that to me. Wasn't that the last chapter, the order? No, it's everywhere. It's everywhere. Okay. We've already talked about this, but real quick, just to reinforce this idea. What is this, and what's this? What's the first guy? And what's the second guy? Yeah, the first guy is
Undefined.
Undefined.
Because nothing times 0 equals 6.
The second guy is
0.
0, because 0 times 6 is 0. See, that works. There's nothing I can put there to multiply 0 and get 6. That's why it's officially undefined. We don't have anything defined to do that. How are we feeling about that? Semi-decent? It will be, yeah. I don't have it instantly streaming yet, but it will be up there. Okay. The only other little thing I want to talk about is section 2.5. Here we go. Here's what we're going to do. We're going to do a couple problems out of 2.5 together. Next time I'm going to have you guys do, the first thing we'll do is some group work out of 2.4 and 2.5. 2.6 is the one I definitely want. Like, we're going to be here all day next time. Not all day, but all class. I really want to focus on the last section in chapter 2, which is solving equations. Right? The solving equations. If you come out of here with a decent handle on solving equations, Math 90 will be so much easier. The solving equations shows up in almost everything in there. So if you can solve equations, you're that much ahead in the game. The section 2.5, we've already talked about order operations. In fact, we will never stop talking about it because it's true everywhere. The please, excuse, we'll just stick with my dear on sale. Because I've actually had somebody be offended by me saying my dear my son. I'm like, well, if you're offended, then just wait a minute, I'll probably do it. So this means, what does this mean the way I write that?
As it comes.
As it comes, I love it. So it could have been pen massage, it's easier to say pen mass. But I want to focus on a couple of these that get a little more difficult than what we've seen so far. So this section just gets a little tiny bit more into it. So we'll see something like this here. Yeah. Oh, yeah. Let me change that one up a little bit. Yeah. I'll make it a little different than the problem in the book. What do these mean?
Square root, I mean,
Absolute value.
absolute value.
So I try on the board, it might be not as easy, but on the paper you can definitely tell it's absolute value. It's not 18 minus 241. Right? It's the absolute value of 8 minus 24. Where do they show up in the order of operations, absolute values?
T.
Where do they live? Yeah, they're the same thing as parentheses. They're just parentheses that have straightened out their lives. I don't know. Right, so they're the same location in the order of operations. So you have to do in here first. So what is 8 minus 24? They're different signs.
24 minus
So you subtract. 24 minus 8 is 16. And then the bigger one is
8. Minus.
negative. Yes, sir.
Why was it negative? Well, what made it negative?
Haven't
The
dropped.
fact that the bigger guy is negative. Right? Do I have more money or more debt?
One day.
In this case, I got more debt, right? The bigger one's negative, so my answer should still be negative. I haven't quite crawled out of my debt hole yet, right? Okay. Everybody's so good? So good so far? There we go. So far, so good? So the only thing we did is change that one thing. And I'm going to keep reinforcing this, especially when we get into solving equations. So often students know what to do, you guys just get lost in your own work because you're not very organized. And I can't talk too much against it because I'm not the most organized guy in the world either. But my math sure as all hell is organized because otherwise it's difficult. So don't let that be what screws you up. Change one thing, everything else comes. Now change the next thing, everything else comes. Right? What do I do next?
Multiply.
Take it out of.
Yeah, I'm not done with the absolute value yet, right?
Change it to the.
Exactly. So absolute value is here. It's got parentheses don't do anything themselves, but absolute values do. So you actually have to do that thing. It's going to make the negative 16 become 16. I don't really need the 4 in parentheses, but I'm just doing it. And now what do you do?
Multiply and divide as it comes.
And why do you do multiplication here first? Just because it came
First.
I love it. Not because m is before d. No. So what is 16 times negative 2?
Negative 32.
Good. 32, and it's in negative because it didn't die. Divided by 4?
8.
Beautiful. Negative 8. Because 32 divided by 4 is 8, but the negative, nobody killed it, so it's still there. I love it. How are we doing? So that is a little more difficult than the ones we've seen so far, the order of operations, because I threw in there an absolute value at the same time. It's going to be some negatives scattered in there. Right? Yes, sir.
So absolute value is always positive, right?
Absolute value always makes it come out positive, or at least 0. Right? Absolute value is 0, 0. Yeah.
But if you, let's say if you lift the negative, negative 16 times negative 2 would make the.
It would have been a
Oh,
positive
positive.
32, that's right. It would have been.
Oh, wait.
But then negative died from the absolute value, so it wasn't there to kill that guy. Right? Okay. All right, so let's try another one. With a different kind of...
Can you do 57 in that section?
That is so weird. Because that's exactly what I was going to do. You're freaking me out. Get out of my head. Let's see. So, here's a clue. The people that do math really well are not necessarily smarter. They're not necessarily understand everything better. It's just that they're able to see math for what it is. A bunch of small problems inside of a big problem. So when you look at this problem and you say, I think I'll skip that. Hopefully you won't notice. And just because it's got a lot of stuff going on, you got to start to break it down into its parts. I've got, for example, this bar naturally breaks it up into top and bottom. So I could just cover that up for right now. So now the problem looks a lot better already. Right? So you can actually put a piece of paper up there if you need to. Just so you're trying to tell your brain, calm down. You don't have to worry about the bottom yet. Let's just focus on the top. What are you going to do on the top first? They went a little parenthesis happy up there, but
Multiply.
Good, I'm going to subtract last. I've got to multiply first. So what's negative 7 times negative 3?
Positive 21.
Positive.
Good, the negatives cancel. You get 21 minus, beautiful, 4 times 3 is 12. Let me stop right there, you guys. So I didn't care about the bottom at all. I don't even care what's down there. It could be the weirdest thing ever seen, and I don't care because I just got to worry about the top. Now I got to worry about the bottom. Who remembers those brackets? What are they?
Like parentheses.
They're just parentheses. They're just a different form, so it's easier to kind of group them. Right? This goes with this, and this goes with this. Cool. So what do I do first?
Parentheses within the brackets.
Beautiful. I got to do in here first, and in here I've got to do in here first. It's that old Russian doll thing. You do the innermost first. Cool. So what's 3 minus 10?
Negative 7.
Negative 7. That's right. And do you see what I've kept the form. Something minus something divided by 3 times stuff. The form is still there. I've only changed that, and I've changed these 2 things. I mean, I've still kept, everything else just came. And I swear to God, somebody in here is not going to do that. They're going to do bits and pieces of it, and you're just not going to know how it's supposed to go back together, and you're going to screw yourself over. When you probably are, you know what to do. You're just messing yourself up by not keeping the form together. What's the next thing I can do on the top?
Subtraction.
Subtract. 21 minus 12.
9.
Beautiful. That's a really easy one to say 11, because your brain turns things around a little bit. What do I do next here?
Negative 1.
Divide.
Good, you got to do in here first. 7 divided by negative 7.
Negative.
Good, so on the bottom, we're not done with the bottom yet, so it's negative 3 on the bottom. Is that cool?
Negative 3.
And then 9 divided by negative 3 is?
Negative 3.
I love it, because 9 divided by 3 is 3. Nobody killed that negative, so he's still there. Yeah. So this is 3 minus 10. So there's different signs, so you subtract 10 minus 3 is 7, but the bigger one is negative. So I got more debt in that case. Yes, sir.
You're supposed to do the first, but would it not have worked the same if you had done 3 times 7 divided by negative 7? Or is that for just,
In
is
this
that a coincidence
case,
for this
in
particular
this
problem?
case, yes, it would work. But you got to really understand when it would and when it wouldn't. So right now, I'm trying to do everything by the book. The further you get in math, order operations is still there. You just start to get more comfortable with doing things more, or just kind of breaking the rules a little bit by the book. You could do the 3 times 7, sure, and it wouldn't change a damn thing on the bottom. But in general, when are you allowed to do that? I can't say. It's not a general rule. It's just a realization for each thing. So for right now, stay by the book unless you're comfortable with it. Do it a different way. Anything else about that problem? You're all excited now that I said we're going to leave it alone. Like now? Is it now? Is it now? Let's see. Maybe it is now. Let's see. What time is it? I can't even see it. All right. Sounds about good. All right. So what we're going to do next time, we will start, like I said, with that group work on 2.5. We'll go over into 2.6. Spend the rest of that day just talking about solving equations.